All right. So, a couple things up the top. Got a couple emails. I have no idea what Top Hat was doing. Resynced one of the class participations. I just had to go in. It was treating everyone as late, showing a 0. So it should look fine now. There will be someone that just asked me, kind of delayed a little bit, and I've moved it to thinking about the topic for next week, which is there will be a third pack back before this upcoming exam. So I'll have it set to be released on Friday, on Monday. It'll be kind of related to that module reading, right, for chapter 9. It'll probably be a little bit easier to kind of write out some thoughts after we have class on Tuesday. But it'll be related to what we're talking about next week to start to kind of get you to think about firm costs going into kind of that exam. So it'll be released Monday, due the following Tuesday. So you have about a week to get on, get it done. Should be easy points. Should be the last thing you need to do. You won't have any more module readings next week because we don't cover module 10 before the exam. So you'll have a module 8 quiz that will get released after we have class today. The last module 9 reading before the exam, which is kind of 2 weeks ahead of us. Those are both due when? Module reading and quiz are due at the end of the day, Monday, right? So we'll talk more about that pack back assignment in class next Tuesday, but you might see it pop up on Monday when I'm in my office. I'll probably get it set to be released. You can kind of start taking a look at it. Then once we talk about it in class Tuesday, it'll be a little bit easier to kind of respond to, okay? Other than that, I think I don't have any housekeeping stuff. So unless there's any questions for me. Oh, CL sessions kind of, same kind of back to normal this week. The material is getting harder, so I can't stress enough. Seeing more problems to work through. We can cover the material in class. We don't have as much time to work through as many problems. Those CL sessions, kind of smaller groups, you can really work through a lot of those practice problems. Ask the CL leaders questions. They don't have to just be on the practice problems. Maybe you have, what if this happened? They can kind of try to help you work through those. Okay. Any questions for me before we jump into material here today? Okay. So we left off with these examples. We didn't complete this one. We had time. We'll kind of go back and work through it. But I wanted more so to remind us where we left off, which was we were saying when people spend optimally, what was going to be true? We were choosing to buy whatever had the highest marginal utility per dollar we spent, right? So we said at that optimal point, the marginal utility per dollar of the last two of each of these goods should be the same. We'll kind of prove that to ourselves, and I think in a better way today, but that's kind of where we left off. So what we're going to start talking about today, and I'll probably go through this relatively quickly, but it shouldn't be too tough, are these indifference curves, right? So all an indifference curve represents is the different combinations of the two goods that we're thinking about. And we can make this more complicated. We could do several goods, but we're just going to keep it at 2. So it's any combination of these two goods that would provide me with the same amount of total utility. So you can imagine if I have a lot of Y and a little of X, or a little bit of Y and a lot of X, maybe those provide me with the same total level of utility, right? So our indifference curves are going to look something like this, right? They're going to represent that there's all these different combinations of the two goods we could buy, and we'd be equally as well off. We'd have the same total level of utility. Now, they're going to have to be downward sloping. Why? If I want to keep utility the same, if I buy more of X, what do I have to do? Buy less of Y, right? There's this trade-off. If I'm trying to keep total utility the same, when I get more utility from buying more of good X, that would have to be compensated by reducing the amount of good Y I'm buying. So we have, keeping total utility the same, we're going to have this downward sloping relationship, right? Once again, just X and Y good here on our axes, okay? So that's not too crazy. The other thing we'll think about is higher indifference curves represent higher levels of total utility, right? So if you think about Y, if I were to look at the same point here, A and C, I have more of both goods at point C. So how could I be worse off than when I was at point A, right? So moving to these higher indifference curves, curves that are further from this point where we have nothing, 0, 0, higher indifference curves are going to represent a higher amount of total utility. Okay? I'll kind of give you another kind of look at this here in a second. Now, the third property we're going to have, well, this one, right? If we're at here, maybe it could be that I have more of one good, but less of the other. I could still end up on a lower indifference curve. So we'll kind of think about why here in just a second. But before we kind of go to me writing something out for you, the other thing that we're going to have true about indifference curves is they cannot cross. So let's think about why they can't cross, okay? So let's say I have any two goods, and there's all these different combinations of these two goods I could buy that would provide me with the same amount of utility. Let's just say it's 100 units. We know how we're measuring utility at some level of happiness at this point. Let's say the level of utility is 100 here for all these different combinations of these two goods. If I had an indifference curve that's up here, call it 300, why do I know that has to be a higher level of utility? Well, I kind of have these arrows thinking about if I have more of both goods. But maybe a better way to think about it is, if I have the exact same amount of X, but I have more of good Y, what's going to be true about my total utility? It's going to be higher. I'm getting the same amount of utility from the amount of X I'm buying, but now more utility because I'm buying more of good Y. Now this is total utility. Okay? So why can't these curves cross? Well, if we think about a scenario where I did have them crossing, so sometimes we can kind of disprove things to ourselves by saying, well, what if it was true? Well, under this scenario, if I think about this point compared to this point, I've got the same amount of good X, but more of good Y, so my utility should be higher. Okay, that part makes sense. But if I look at other quantities of X, notice what's true here. If I'm at this quantity of X, if I have less Y, what should be true about the utility? I've got the same amount of X, I've got less of Y, my total utility should be, this would not be less, right? So that's why we can never have these indifference curves crossing. It has to be, but the gap can get small, right? But they can never cross. Now, in general, the way that I'll draw these indifference curves and the way that we'll think about them for this class, we can complicate it, we won't do that. Just think of it as parallel shifts, right? So I'm trying to draw these increases in utility as just kind of these parallel shifts in our indifference curve, okay? But we can never have them cross, right? So if you're thinking about this, like, it can't cross, okay? Other questions at this point? This one shouldn't be too bad. So I go back and forth. I don't like my slide as much as what I think I can do here to really like make a extreme point. So let's say I have two of these goods, right? And I'm thinking just now about one indifference curve. Call that level of utility 100. If I'm thinking about here, right, maybe I only have a very, very small amount of good X, but I've got a lot of good Y. What's going to be true if I want to get one more unit of good X here? What's going to be true about the marginal utility of that second unit of X I buy? It's going to be relatively. So as I buy more of something, what's happening to the marginal utility? So it's decreasing. So when I'm at really low values of X, the marginal utility is still relatively high. I don't have a lot of it yet. So in order to get one more unit of good X, how much of good Y would I give up? Well, if I've already got 100 units of good Y, what's true about the marginal utility of that 100th unit of good Y probably? It's relatively small, right? As I have more of something, that marginal utility is getting closer and closer to zero. So if I want one more unit of good X and I don't have a lot of it, what's probably true? I'd be willing to give up a lot of good Y. Because I've already got a ton of it. It's not, all of these units aren't providing me with that much additional utility. But that one more unit of good X is going to provide me with a lot of additional utility. Right? You can kind of think about a scenario, let's say here, the marginal utility I get from that second unit. So I don't know, we'll call it, it's not squared, but we'll put 2 here. It's something like 20. If the marginal utility, no, here, do 100, right? Of those last units of good Y I was getting, let's say they were only 2. To get one more unit of good X, how much of the Y good would I give up? So if I get one more unit of good X, the additional utility I get is 20. So to keep total utility the same, how much of Y would I be willing to give up? Yeah, 10 units, right? Because each one would have a marginal utility of 2. And then my total utility, right, we're thinking about, remember, on my indifference curve, total utility is remaining the same. So it's how much of that Y good am I willing to give up to buy one more unit of X that would keep my total utility the same. Now, what's going to happen if I'm then thinking about, let's say, I don't know, I've now got 50 and 51. I tried to kind of draw this to scale, right? Well, I now have a lot of good X, not a whole lot of good Y. So what's going to be true about the margin utility of X when I've got like already 50 of them? It's going to be relatively low. Let's say I only have, I don't know, let's do this from moving from 10 to 9 for Y here, right? So what's going to be true about the margin utility of Y when I don't have a lot of it? It's going to be relatively. So to get one more unit of good X, I'm not going to be willing to give up very much of good Y, because the additional utility good X provides me when I already have a lot of it is relatively small. So this trade-off between the two, what was happening? Initially, I was willing to give up a lot of good Y. As I had more of X, I was willing to give up less and less. The slope of our indifference curves is going to tell us about kind of the trade-off that we would make between the goods X and Y to keep total utility the same. But that won't be constant. Notice we don't have a linear curve here. The slope of this curve is doing what? Becoming flatter. So what we'll end up seeing is that kind of the cost in terms of how much utility we're giving up from good Y to get one more unit of good X, it's getting smaller and smaller. All right, we're willing to give up less and less of good Y as we have more good X. We'll kind of paint this in a different picture, but just kind of setting up the concept here, what we're going to talk about. That rate of substitution, or how much I'm willing to give up with Y, is going to be different at different points on our indifference curve. So that leads us to our fourth point, right? Which is that they're going to be bowed, kind of inward, right? They're not linear. They kind of have a changing slope, okay? Excuse me. So I had some different numbers here, thinking about if I wanted one more unit of good X here, I was willing to give up 6 units of good Y. Down here on my indifference curve, I'm only willing to give up 2. I chose more extreme examples to kind of really amplify this idea starting out. So let's think about how can I determine what this rate of substitution between the two goods are that would keep me at the same level of total utility, right? So what we're going to call this, I'm going to kind of skip ahead here, is our marginal rate of substitution. So we already said this marginal rate of substitution, how much of Y I'm willing to give up to get one more unit of good X, it's going to be decreasing as I have more and more of X. That's represented by the slope of our indifference curve. So what is the slope of our indifference curve going to be, right? Well, you can kind of think about it here. I'll jump the gun and then go back. So, So that slope of our indifference curve, I'm telling you for a second that it's going to be the margin utility of good X over the margin utility of good Y. Okay? Well, we can kind of think about Y. So remember down here, when I was saying the margin utility of one more unit of good X was going to give me 20 units of additional utility, but each unit of good Y was only going to give me 2, right? Well, how did we determine how many units of good Y we were going to give up? Well, we said it was 10, but what were you really doing in your head there? You were taking the margin utility of X, dividing it by the margin utility of good Y. So notice that would have given us, we were willing to give up 10 units of good Y to get one more unit of good X. So that slope of our indifference curve is going to be what we call the marginal rate of substitution, which is just this relative, this ratio of the margin utility we get from one more unit of the X good relative to the margin utility we get from one more unit of the Y good. And you can kind of think about it. If buying one more unit of X gives me 100 additional units of utility, or each unit of good Y was only giving me 1, how many units of good Y would I be willing to give up? 100. Right? To kind of keep total utility the same. So this looks a little confusing, and I think some people had some issues with what we talked about on Tuesday. They're like, well, what? I think I can kind of maybe help iron these out a little bit. So when we were talking about budget constraints, you can calculate slope how? If I just have any line, how can I calculate the slope? It's the change in. Yeah, but notice here, this is like the general term. What are our X and Y? What's on our axis? Well, this is actually like the change in the quantity of Y and the change in the, quantity of good X. So when we have the slope of our budget constraint, I think some people were a little bit confused. Why is the slope the price of X over the price of Y? Well, I worked through and I kind of started with the budget constraint, rearranged things to kind of show you how we get that slope. You can do a very similar thing, but with our marginal rate of substitution. Now, I'm going to make kind of an assumption here that's not quite right, but just to kind of make it a little bit more simplistic, let's assume for a second that marginal utilities for two goods were constant. Just to make it easier for a second, so I can kind of show you where that marginal rate of substitution is coming from. Okay. So if I wanted to keep total utility the same, and I'm buying two goods, if the marginal utility is constant, right, how much total utility am I going to be getting from good X? Well, it's going to be the marginal utility each unit provides me times what? Each unit gives me an additional 5 units of utility, and I buy 5. The total utility from good X would be, if I buy something and it gives me 5 units of utility, I then buy 5 of them. My total utility will be 25. What did you do there? You took the marginal utility from each unit and you multiplied it by how many units you were buying. Now, total utility is the sum of how much we're getting from both goods. So what's the total utility I get from Y? The additional utility that each unit of Y gives me times the quantity of Y I'm buying. So this is very similar to what? What does this look like? Talked about last class. If I just replace this with income and my marginal utilities with prices, looks like a budget constraint. It's kind of similar, except for now we're saying to keep total utility constant, to stay on that same value, that same curve, that same level of total utility, this has, like, we're going to only be able to buy certain combinations of these two goods. Well, I've got the quantity of Y on my x-axis. I've got the quantity of X on my x-axis. I want to get a function that looks more like what I would need in math, right? Y equals mx plus b. What's my Y? The quantity of Y. So I'm just going to solve this function for that. So I can go through, I'll subtract this. You don't have to do this algebra every single time. But if you wanted to, right, you'd have the total utility minus the marginal utility of X times the quantity of X. It's equal to the marginal utility of Y times quantity of Y. Divide both sides by the marginal utility of Y. And you'd end up with that quantity of Y, what your Y variable was, is going to be equal to the total utility over the marginal utility of good Y minus the marginal utility of good X divided by the marginal utility of good Y times the quantity of good X. Now, we aren't keeping marginal utility the same, so this doesn't quite work, but this is the general idea. When I'm looking at the quantities, yes, I calculate slope as the change in the quantity of Y over the change in the quantity of X. But when I'm thinking about the slope in terms of the marginal utility of the two goods, notice what's on top, the X good, right? It's how much additional utility of good X I'm getting relative to how much additional utility I'm getting from good Y. Now, this doesn't really quite work because this would give me a linear curve. In theory, what ends up happening is there's a function for marginal utility, and we said as we buy more, what's happening to marginal utility? It's decreasing. So I plug those functions in. The math just gets a lot more complicated. But what ends up coming out of it still would be that this slope is the relative marginal utility of good X to the marginal utility of good Y. So when we're talking about calculating slope using quantities, whether it's indifference curves or the budget constraint, it is changing quantity of Y over changing quantity of X. When we're talking about the slope, calculating that from either prices, if we were dealing with a budget constraint, or marginal utilities, and we have indifference curves, there X is on the numerator, in the numerator, not on the numerator, right? In the numerator. Yeah. Yeah, right? If I have Y is equal to mx plus b, I guess here's my b, here's my m, that's my slope, right? So that would be the slope of my indifference curve. Now, like I said, I simplified it here. This is linear. We don't have a linear curve, but just to kind of paint the idea of why that X good is on top. Right? I know it seems a little counterintuitive because when we're calculating slopes, it's changing Y over change in X, but that's because our graphs are using quantities, not marginal utilities. Okay? Any questions on that before we kind of hop back to the slides here? Okay. All right. So, we're gonna already talked about why does this have to be true. and I kind of gave you some hypothetical numbers. If I'm getting 20 additional units of utility from good X, every unit of good Y gives me 2, I'd be willing to give up 10 units of good X. It's going to be that ratio of the marginal utilities. Okay? So let's think about an example, working through like a problem. Excuse me. And here, I think I've gotten my slides. I want point A, point B. What I actually want, I think all this has, I flipped these. So let's say this will look a little bit, make a little bit more sense. All right. So let's say I'm moving from point B to point A. Well, if I'm using my quantities here to calculate slope, what's the slope of my indifference curve? Well, going from B to A, how much is Y changing by? It's going up by, going from 3 to 5, so up by 2 units, divided by my change in X. How much is X changing by? 1 unit, so it would just be 2 over 1, or technically 2 over -1, right? So -2, right? We always have this downward sloping indifference curve, so it's always going to be negative. Now, what would my marginal rate of substitution be in between these 2 points? So the marginal rate of substitution is the same as the slope of our indifference curve. So I can still use my quantities to calculate slope, but once I have that slope of -2, what's my marginal rate of substitution? If it is the slope, and the slope is -2, -2, right? So I can use the quantities to find that marginal rate of substitution without actually knowing what those marginal utilities for each good actually are. Kind of going between 2 different points. Let's say I'm going from point D to point C. What would my marginal rate of substitution be? Well, I'm going from what? 1 unit of good Y to 2 units. So my change in Y was 1. How much is X changing by? I'm going from 7 to 3, so it's going down by 4. So what's the slope of my indifference curve here? Change in Y over the change in X, -1/4. So my marginal rate of substitution would be -1/4. It's just that slope of my indifference curve. So notice what's happening as I was moving in this direction. If I move to higher levels of that X good, my marginal rate of substitution started out as -2. So what that's telling me, for every additional unit of good X I want to get, I'd have to give up 2 units of good Y. And then as I have more of X, what should be happening to that marginal rate of substitution? It's getting, well, if my curve is getting flatter, then that marginal rate of substitution is getting closer to 0. Sure enough, once I'm looking up here at higher quantities of X, what's my marginal rate of substitution now? -1/4, right? It's getting closer to 0. So as we have more of a good, our marginal rate of substitution, what we're willing to give up of the other good, is getting lower and lower. Yeah.
So where would you be able to solve the marginal utility just by looking at that?
I'd have to know one of the other marginal utilities, right? Because if I know the slope, that is my marginal rate of substitution, but that's the ratio of the 2 marks. So unless I know one of them, I can't solve for the other, right? But even without knowing them, if I've got quantities, I can figure out what that marginal rate of substitution is, what that ratio of the 2 marginal utilities are. Yep. Any other questions before we keep moving here? No? Where are we at with time? All right. All right. So, wait, yeah. So what are we trying to do, right? So kind of going back to last class, kind of set us up with some stuff about these indifference curves. Now let's try to think about, when we want to choose the optimal consumption bundle, what are we trying to maximize? So we said we find that optimal bundle by choosing whatever has the highest marginal utility per dollar. But if resources were unlimited, what would I want to do? Just buy more of everything, right? I want to get to the highest level of possible total utility. So my goal is to get to that highest indifference curve possible, right? Get the highest level of happiness from what I'm consuming. Now, we know that we can't just spend off into infinity because there we go. We've got a budget constraint, right? We can only afford certain combinations of these 2 goods, right? I only have so much income, and these goods aren't free. They have prices associated with them. So we're going to think about, how do we choose that optimal consumption point? So I've got a kind of textbook answer here, but kind of, I think, building it through to make a little bit more sense. So let's assume that I've got two goods. Here's an indifference curve. And currently, my budget constraint looks something like this. So all the points that I can afford that would give me this level of utility, I would call it 100, right? I could afford a bunch of different combinations of these two goods that would all give me a total utility of 100, right? They're underneath my budget constraint. I can't afford them. But what's going to be true? If I think about here, I've got higher indifference curves. If I have a level of utility of 100, if I'm trying to maximize total utility, given my budget constraint, what can I do now? Well, there's different combinations of these goods that I could buy and be on a higher indifference curve or obtain a higher level of happiness. So what am I going to do? I'm going to move my consumption to one of these points, right? I can still afford them. They're still underneath my budget constraint. I'm going to do this until I get to an indifference curve. I'm trying to draw these parallel. I'm doing the best I can here. We're going to continue to change our consumption habits until we get to an indifference curve where there's only one point on that indifference curve that we can afford, right? There's only one point where it hits that budget constraint. Now, if I think about here, I'm on the highest indifference curve I can possibly get to, given my budget constraint, because even if I was thinking about moving to a slightly higher indifference curve, every point on that indifference curve is now past my budget constraint. I can't afford them. So this consumer optimum will be the point where I'm at an indifference curve that has one single point that intersects with my budget constraint. Now, I tried to draw this kind of to scale. I'm going to be jumping the gun a little bit here, I think. But what's true about the slope of my indifference curve and my budget constraint at that consumer optimum point? It looks like they're the same. In fact, they will be, right? So let's kind of think about what that means for us, right? So what's the slope of my budget constraint? Going back to last class, that was just my relative price of good X to the price of good Y. Okay? What is my marginal rate of substitution, or the slope of my indifference curve? That was negative marginal utility of good X relative to the marginal utility of good Y. If I rearrange things here a little bit, I divide both sides by the price of X, multiply both sides by the marginal utility of Y. This cancels, this cancels. Now I've got the marginal utility of X over the price of good X is equal to, oh, sorry, I flipped them. This was on this side. I've got the marginal utility of good Y over the price of good Y is equal to the marginal utility of good X divided by the price of good X. There's a negative sign on both sides. Multiply both sides by -1. That would kind of cancel. What ends up being true at that consumer optimum point, or the point where I'm maximizing my total utility, the marginal utility per dollar I'm spending on both goods is the same, right? So we said last class, people will choose to buy whatever has the highest marginal utility, and go back and forth until we get to this point that maximizes total utility. Given our budget constraint, that point will be where the marginal utility per dollar of both goods is exactly the same. And you don't have to do this math every single time. We just have to know that that's the kind of end result of the fact that when we're spending optimally, the marginal utility per dollar of both goods is going to be the same. Okay. Any questions on this before we keep moving? I'm going to do this kind of quickly, and I won't ask you a bunch of questions on it, so don't worry too much. But I think it will maybe help, right? So let's say I was kind of at this point. So if I was at a higher point here, what has to be true is the ratio of these marginal utilities per dollar is not going to be the same, right? So I might have the marginal utility X, margin utility for good Y. So what do I want this here? If I'm at a point up here, as I buy more of X. So let's say we started out something like this. If we were at a point that isn't at the consumer optimum, what's going to be true at this point, and I'm not going to expect you to know this, but this would be the case. We could work through it if we had more time, that the marginal utility per dollar on good Y is actually less than the marginal utility per dollar good X. And that kind of makes sense. I have more of Y here, so the marginal utility is going to be a little bit smaller. I have less of good X, the marginal utility is going to be a little bit higher. So first of all, I can't even afford this point, right? But how could I kind of move to this point where I'm maximizing my total? Well, as I buy more of X, what's going to happen? The margin utility is going to go down. As I have less of Y, the margin utility is going to go. So what will end up happening? I change my consumption habits until this is no longer less than, and these are equal to, right? So any point that I'm not at that consumer optimum, this equality wouldn't hold, but if the equality doesn't hold, I know that I should be buying more of the thing that has a higher margin utility per dollar. But as I buy more of it, what's happening to the margin utility of the last one I bought? It's going down. So this change in spending habits towards the thing that has a higher margin utility per dollar will lower that margin utility per dollar until these two things are back to being equal. Now, once again, I'm probably pushing a little bit further here than I would maybe ask you questions on, but this is kind of the idea of what's going on. We're thinking about these consumer optimum points. Okay. Any questions on anything here before we keep moving? Yeah. Basically, right? If we thought about like putting a margin utility per dollar to every single quantity here, that's exactly what that would be. Yep. Any other questions before we keep moving here? All right, so let's next think about, we've already talked about all of this. I kind of did this for you, right? The end result was that consumer optimum is where margin utility per dollar is exactly the same for both goods. Right? So let's think about things that are going to change where our optimal consumption point is. Right? So I'll do an easy one first, and then we'll kind of come back to this slide. Right? So let's say I have any two goods, and I'm facing this budget constraint, and all right, the highest indifference curve possible I can get to with something like this, right? So here's my optimal point, the point that's maximizing total utility. So just intuitively, if I have more income, what do you think is true? I can buy more of both goods, right? Or if I have more income, we said there are going to be points that before that were unaffordable that we now can't afford. So if I think about an increase in income, we said, what does that do to our budget constraint? It doesn't change the relative prices. Remember, the slope of our budget constraint was just price of X over the price of Y. Well, if income changes, that doesn't change that at all. So when I have an increase in income, what's going to happen now? Well, there's now all of these points that I couldn't afford before that I now can. What's going to be true? Well, there are now indifference curves in this range that would provide me with higher levels of utility than I can now afford. So what am I going to do? I'm going to start to buy more of both of these goods until I get to the new highest possible indifference curve I can get to. So increases in income will kind of shift that budget constraint out and allow us to get to higher levels of total utility. I have another way of kind of connecting. Like I said, I've gotten some emails and I understand there's some confusion about Y versus X. What did we say the two extreme points were for a budget constraint? How would I find out how much, if I'm only buying good Y, how much can I afford? We said we would take our income and divide it by what? Price of good Y. What was my extreme point over here? My income, if I'm only buying good X, divided by the price of good X. So if I wanted to use these quantities, remember, these are representing quantities. On a graph, usually we were seeing things like, 40 and 80 or some actual numbers, but this is where those numbers are coming from. So if I'm moving from this point to this point, what's my change in the quantity of Y? What was going from M over price of Y to 0? So, and I might have done this last class, but just to kind of reiterate it, what was X changing by? The quantity of X. It was going from 0 to M over the price of good X. They have the same thing in the numerator. That cancels. These would be 1. A fraction over a fraction, or a fraction divided by a fraction. Everything flips, and I just end up with this would be the slope of my budget constraint. So yes, we calculate slopes using the change in quantities. Remember, this represented the change in the quantity of Y, and this represented the change in the quantity of good X. But we're talking about how we determine that slope for, based on prices. Those two things just kind of they get flipped. Now, why? Honestly, just the mathematics of it, right? There's not a lot of great intuition behind why, or we kind of take a much longer time to talk about it. But for the sake of what we're doing, we just know that from this math, we'll end up with that the slope of our budget constraint is the price of X over the price of Y. So kind of trying to relate what we're talking about today to some other things we talked about in the past. Any questions for keep moving here? All right, so I think what I've got up here is a slightly different example. So I don't have a change in income. I think changes in income are kind of easy. If I had a decrease in income, what's going to happen to my new consumer optimum? It's going to be at not a higher level of utility. If my income's decreasing, my budget constraint's going down. So I'm going to only be able to get to a lower level or a lower indifference curve, lower level of total utility. What if prices change? Right? So here's where we're going to eventually break these down into two components. But when prices change, right, we're going to do what? If something becomes more expensive, and we're only thinking about buying two goods, I'm going to buy more of the thing that is now relatively less expensive, less of the thing that's relatively more expensive. Now here, I think I've got what? Pizza and Pepsi. So let's say that, here's my original budget constraint. My optimum point was buying 4 cans of Pepsi, 3 slices of pizza. What would cause my new budget constraint to be this line here? It would have to be that the price of my X good went. So if I'm only buying X, income hasn't changed, but I can now buy less of it. It must be that the price went up, right? Or went from $1 to $2 in this example, right? So if prices go up, right, the intercept of whatever good I'm looking at is going to be lower, right? I'm only buying that because I can afford to buy less of it. So we know that our new consumer optimum is going to be at this now lower indifference. We can no longer afford this point, right? It's past our budget constraint. So the new indifference curve we're on, here I had a weird kind of unique scenario where I end up buying the same amount of good Y, but I'm buying less of good X, right? So this will be what we call the total effect of this price change. There's going to be two things that are baked into this, right? So one, when prices change, we said if the price of Pepsi goes up, what's going to happen in terms of the substitution effect? If something is now relatively more expensive, I will buy less of it, and I will buy more of the other good. But price changes also do something to our income. So even though income hasn't changed in this example, like M is still the same value, what's happened to the real value of our income? Well, if prices are higher, you have the same $100 in your pocket. What's the value of that $100? It's went down. So the idea of inflation, right? I'm making the same amount of money. Everything, I go to the grocery store, everything's doubled in price. The same amount of money in my pocket, I can only buy half as many things now, right? So anytime we have price changes, we don't see a change in income, but we do see a change in our real income, the actual value of that dollar amount income that we had, okay? So if I have normal goods, increases in prices would do what to real income? Drive it down. I can buy fewer things. So if I have less real income, the income effect would be for normal goods that I buy. For normal goods, if I have less money, I buy less of them. Right? So this is where the class, I'm not going to go back and ask you, the types of questions we were talking about. What was that, module 3, I think, right? But we need to know what this relationship is between income and how much people will buy of a certain good, basically if it's a normal or inferior good. Right? So the next thing, excuse me, we'll talk through is this idea of, can we disentangle, now we already talked about it, right? That substitution effect, the fact that because the relative prices have changed, we'll substitute away from the good that's now relatively more expensive towards the good that's relatively cheaper. But there's also going to be an income effect from a change in prices, right? Now, the combination of the two will give us the total effect. Graphically, that was just what 2 points did we move between? That was our total effect. We have a way where we can break this down or disentangle this to be the substitution and the income effect. So what's that going to look like? Right? So let's say we start out, we've got what? The price of soda is $4, pizza is $1. This was my original consumer optimum. Okay. Let's say the price falls to $2. So one way we can just look at the substitution effect is say this. Assuming we could afford to obtain the same level of total utility. So if I have the same level of total utility, and I was maximizing it before on this indifference curve, what that's saying is some point on this curve where I'm keeping total utility the same, but I'm now facing different prices. So here would be kind of our old optimum. After the price falls, well, if the price decreases, what's going to happen? If the price of soda decreases, sorry. Well, I can now buy more of it. So my new budget constraint kicks out. I can now afford to get to a higher indifference curve. This movement from what, 600, 150 to 500, 350, that's going to be my total effect. We can break that down into two different kind of components, the substitution and income effect. So in order to do so, there we go. I thought I had these on notes for once. I'm going to create what we call an artificial budget constraint. So this kind of dashed line here is saying, let's assume that even though prices went down, I know that that's going to do what to my real income? Increase it. I can now afford to buy more. The money in my pocket is worth more. So let's assume that I'm eliminating that income effect. I'm not allowing us to get to a higher indifference curve. I'm saying, even after this price change, you can only still afford the same level of total utility. However, you face these new relative prices, right? So before, what? The slope of my budget constraint would have been the price of X, which was soda, over the price of Y, so 4, right? Once it falls to 2, my new relative price would be 2 or -2 because we have downward sloping. So at this new ratio of prices, oops, I don't want to do these at the same time. This new ratio of prices, but keeping total utility the same, this movement from A and B, it's shut down the income effect, and we're only looking at the substitution effect. We're only looking at the impact of the fact that there is now a different ratio of prices. So our movement from A to B here, when the price of our X good soda went down, we end up buying more of that X good, more soda, and less of our Y good. So that would be our substitution effect. Now, this dashed line is like an artificial budget constraint. It was saying, if we could still only afford the same level of total utility, right? We're still on the same indifference curve, but at the new relative prices, where would that point be? That change in relative prices, that is the substitution effect. That's that component. Now, given these new ratio of prices, the new relative price, but allowing for the fact that we know when prices go down, real income goes up. So now thinking about from our hypothetical budget constraint to the actual new budget constraint, this movement from B to point C, well, we've kept the relative prices the same. So we're shutting down the substitution effect. That movement, right, from our old indifference curve to our new indifference curve at the same relative prices, that's purely representing the income effect. Right? So here, the income effect for both goods was that I bought what? More of both of them. So prices went down, real income went up. If I bought more of both goods, they must both be normal or inferior. So if real income is going up because prices are going down, and I buy more of both goods as from the income effect, they're normal goods, right? So nothing too crazy there. We'll kind of skip this, come back if we have time. I like this, but I think I can draw this out a little bit better. So, or even draw this out to make an additional point. So let me see here. Let's say I've got the quantity of X, quantity of Y. We just did what? A price decrease. So let's do a price increase. So let's say, start out here. I'm going to draw a relatively steep indifference curve. So this was kind of our initial starting point. Let's say the price of, excuse me, Y goes up. Where's my new budget constraint going to be? So what's going to happen here? If the price of Y goes up, which of these intercepts will change? This one. So my new budget constraint might be something like this. So if I think about, let me see if I can get these lines to be parallel here. It's not perfect, but I can think about something like this, right? So from point A to point B, this would represent my total effect, right? In order to kind of break this down, I need to create some kind of artificial budget constraint. Right? So in order to do that, I need to take my new prices and think about if I face those new prices, and this is where I'm doing the best I can to draw these parallel, right? But I was on the same point, or sorry, at the same indifference curve as I started out, right? So here, B is going to be my hypothetical budget constraint. I'm still able to afford the same level of utility I was before, but facing these new relative prices. So the movement from point A to point C, it's keeping the total utility the same, but just looking at the difference between different relative prices, that should represent my what? I think I've heard some people mutter it. If the ratio of prices are changing, that's my substitution effect. So what was the substitution effect after this price change? I bought what? More of X. And just to kind of remember, what was our initial change? We said that was a increase in the price of Y. So I bought more of good X. And what happened to the amount I bought of Y just from the substitution effect? It went down. Okay, that lines up with how we think about substitutions, right? Substitute goods. Now, when I had this price increase, what happened to my real income? Prices go up, my real income goes down, right? So notice here from point C to point B, I'm now keeping the relative prices the same, right? My artificial budget constraint has the same slope as my new ending budget constraint, but I'm allowing for the fact that this increase in prices is causing my real income to go down. So this movement from point C to point B actually did what? The quantity of X I buy went going from here to here, went down, and the quantity of Y I'm buying also went down, right? So what we can end up with here, we know the total effect because we can compare point A to point B. We can see that we actually bought what? More, going from like the old option to the new. We bought more of good X, but we bought less of good Y. We can always break these total effects and these income effects, these total effects down into income and substitution effects. Now, the way we do that is using this kind of artificial budget constraint. Okay. Any questions on this before we keep moving? So I've got a weird, got a weird example. Where are we at in time? All right. This is not the weird example, so we'll kind of go through this, and then I think I have a photo of a visual. If not, I'll try to draw it. It's kind of harder to draw what I want to set up next, but anytime we have these effects, so I kind of use like the arrows to shorthand it. I think that makes it a little bit easier. So let's think about a couple different scenarios. So the first scenario is when we're dealing with normal goods. That's basically the ones that we've worked through up to this point. So if I have a price increase, we said, what is that going to do to the good that has a price increase? The substitution effect says I'm going to substitute away. Right? However, when that price goes up, what's happening to my real income? What's happening to my purchasing power? It's going down. Right? So if it's a normal good, the income effect for that good will also be, negative. So I'll kind of shorthand this here in a second. If they're inferior goods, that same price increase doesn't change how I substitute, right? I'm still substituting away from that good, but when it lowers my purchasing power, if it's an inferior good, what do I actually do? If I have less real income, I would buy more of it. So we can get this really weird scenario. Now, for most inferior goods, it's going to be the case that the substitution effect is larger than the income effect. But we have these really weird goods called Giffen goods where the opposite is true. We'll kind of walk through and think about what's going to happen then with these, what we call Giffen goods. Okay? So for typical inferior goods, this is how we would maybe think about, doing the shorthand. In fact, we got enough time. I'll do normal goods as well. So let's say I'm going to do the reverse of the slides just to kind of show we can go in either direction. If the price of X, and I have to remember what direction we were just doing, was price increases. Yeah, price increases. So let's say we're doing price decreases. What's the substitution effect going to be in terms of the quantity of good X? If it's now relatively cheaper, I'm going to buy more of it. However, what does a decrease in prices do to my real income? Prices are lower. The same $100 in my pocket can buy. So my real income went up. If it's a normal good, then the income effect here will be that I buy. Well, if income goes up for a normal good, I buy. So we know the total effect when the price of a good decreases is that people buy more of it. Well, this sounds like the law of demand. Right? However, we have some other scenarios. So let's say we've got an inferior good. That same price decrease, what's going to be the substitution effect? Relatively cheaper, people will buy more of it, right? Doesn't matter if it's normal and inferior. That tells me nothing about the substitution effect, right? Now, what it does tell me is that when prices go down and my real income goes up, what's the income effect going to be? I actually buy less of it. Now, for typical inferior goods, if that substitution effect, right, is going to be greater than our income effect, what will that total effect be? Well, if the increase in quantity from the substitution effect is larger than the decrease that's occurring because of the income effect, what is my total effect going to be? I still see people after this price goes down buy more of that good, right? So even for inferior goods, this often holds this kind of idea we talk about with the law of demand. Now, the law of demand specifically was talking about like just the relationship of price and quantity of that good, not this idea that we can now substitute away towards other goods and that's going to impact our real income. Right? We even said income changes will shift that demand curve, not change where we're at on it. So the third kind of category we have are going to be these inferior goods that we call, and I think it's EN. No, did I spell it multiple different ways? Because I always forget. Yeah, it's Giffen. I forget exactly how it's spelled. So it's either EN or IN. So it's a Giffen good here. Now, what's going to happen with these goods is that income effects are really large, right? This is going to be goods that are like extreme inferior goods, right? Goods that people don't want to buy. They're only buying them because they don't have a lot of income. Right? So for these goods, if we think about if the price were to go down, same thing, nothing changes. What's true about the substitution effect? Price of something goes down, I will buy more of that, right? I substitute towards that. However, this real income, right? Because prices are lower, real income is going to be higher. So my income effect for an inferior good. So Giffen goods are a special category of inferior goods. So my income effect for an inferior good, if I have more real income, I'm going to buy, yeah, less of it. Well, I just told you the income effects are really large. So if my income effect is ever greater than my substitution effect, what will my total effect be? Well, my income effect was pushing the amount that I'm buying down. If that's greater than the fact that the substitution effect was pushing the amount that I buy up, which one's winning out here? The income effect. So my total effect, the combination of these two are going to be that I see, oh, the price went down and people actually bought less of it, right? So this seems really weird, and you probably don't have a lot of good examples of this in like the US economy. But you know, you can imagine if people are living off of like primarily one good, something like, I don't know, white rice or something like that. If the price fell enough of it, that gives their real income a lot more power, right? And so if that's like all that they're consuming, that's all they're eating, a price reduction in it, yes, we'll substitute towards it a little bit because it's now relatively cheaper, but it makes my income worth so much more. I can now go and start to buy other things, right? So this is pretty rare, but it can happen, right? And it's this, you know, we can understand why because of the fact that we have these competing substitution and income effects going on. Technically, we don't have like a term for that, but you know, here I had an inferior good. For a normal good, it doesn't matter, right? They're gonna get pushed in the same direction. For an inferior good, yeah, we could have these. There could be like a fourth category where they completely offset. Now we would probably just kind of classify that as category 2 because it didn't actually push the quantity down. But yeah, in theory, you could have these effects where they equally offset each other. Let me push this off the screen. Any other questions here before we keep moving? Yeah. So this was just that we have two types of inferior goods. These are kind of our typical goods where we would still see the quantity go up. If this sign ever flips, where the income effect is larger, that's what we're going to be calling the special category of inferior goods. So maybe if you want to do this, I probably should have done like 2A and 2B, right? But we think of, here's our normal goods, here's our typical inferior goods, and here's this unique case, which is an inferior good, but it's a Giffen good, where that income effect is going to be larger. Yep. The questions on that before we kind of go back here. All right. What else do I want to do here? This isn't what I want, right? Because this is going to tell me total effect. We actually bought, well, we can work through it. I think we got enough time to work through this one. So let's say I kind of had this example, and I'm choosing between buying two different goods. Here's my initial, actually, what was my initial one? Yeah, here's my initial budget constraint. The highest difference curve I can get to is point A. After this price change, so what would have to be true if I can now buy more of this x-axis good, so this really cheap whiskey, what's happening to the intercept point? It's going up, so it must be that the price went down, right? So I'm seeing a price decrease. As a result, the new point I can afford to get to is point C, right? So the total effect here is that I'm going to buy more of both goods. So I'm not going to have a Giffen good here because we know the total effect for a Giffen good would be that once I see a price decrease, I'm actually going to buy less of it. But we can kind of walk through this. This might be an inferior good. So we thought about where's this artificial budget, right? So assuming that we're on the old budget constraint and being able to afford the same level of utility we were on that old budget constraint, but allowing for the relative prices to change. So this dashed blue line, we're assuming that we're still only able to afford the same level of total utility that we were originally. However, we're thinking about if we face the new relative prices after this price change, what would that look like? So here, my substitution effect, moving from point A to point B, I'm now buying more of the X good, which is what we saw the price go down. So that makes sense. That's our substitution effect. And we bought less of the Y good, right? It's now relatively more expensive. However, the income effect in this example would be that, okay, facing these same new relative prices, right? So this blue line, our new relative prices, that was what we were using for our artificial budget constraint. So facing those same relative prices, but now allowing for the fact that these lower prices led to my same income having more real value, that movement from point B to point C here, notice what was the income effect for my X good? I actually bought a little bit less of it. It's hard to, it's just barely less, but we did buy a little bit less. So when prices went down, what would that do to my real income? Increase or decrease it? Increase it. And as a result, I bought less of this good. What must it be? Inferior, right? I have more real income, but the income effect, this movement from point B to point C, is that I actually bought a little bit less of it, right? Now, the income effect for this other whiskey, Hotel Tango, which you guys aren't 21, but once you are, you should go there. It's in India. It's a really cool place. They give a bunch of money to veterans and everything. It's neat. Anyways, the whiskey's good too. But we would see that we increased the amount we bought of that. So our income effect, the fact that we had more real income, we bought more of the Y good must be a normal good. Okay? Now, you can imagine if I ever had something where my new kind of income drove, it would be really weird. But let's say my indifference curves look something like, I don't even know if I can get them to match up here. We'll keep this here. And let's say my new indifference curve looks something like this. Oh, need it to be a little bit steeper. There we go. So let's say that was my new point. My new point C, oops, was out here. Well, now my total effect going from A to C was that after I saw a price decrease, I actually bought less of that X good. That would be a representation of a given good, right? Where the total effect is that once the price decreases, I actually buy less of it. But pretty rare. We don't see this very often, other than kind of knowing that relationship of the income effect to the substitution effect. That's probably about as much as far as I'll push you in terms of Giffen goods. But we can do all these other, like what was the substitution, what was the income effect, using the shorthand. We can use visuals to kind of break those two down using our artificial budget constraint. Those would all be fair game. Okay. All right. I'm going to undo all of these so we go back to the original slide. Okay. So what else do I want to do? We got quite a bit of time. Yeah, I'm not going to ask you questions on that. So here's kind of a weird one. Well, I'm not going to ask you questions. I don't want to confuse you. So I think we'll stop there and go through a few questions. Okay. And I'll kind of bring up some points along the way.